This is Advanced Math, Spring Final Review, Unit 9, Worksheet 4. This one's all about our conic sections. So this one says state the vertex. We've been completing the square to get our vertex. So I'm going to add my 13 temporarily to the other side. I'm going to have y equals no y plus 13. I'm going to factor that negative 2 out. Okay, I'm going to need to add a third term to complete my square. So I'm taking that negative 6, I'm dividing by 2, that's negative 3, and then I'm squaring it, that's 9. And then I have to take the negative 2 times 9 and add that to the other side. That's negative 18. So 3 plus negative 18 is negative 15. X minus 3 squared. Okay. So my vertex is my HK, which is 3, 15. And I don't have to move it over to C, but when an H or a K is by its XY pair, it's always opposite. Okay, equations. Okay, I always like to do a basic sketch. Vertex, focus, parabola. I'm going to plot that point for negative 2, 1, negative 2. Okay, the focus is inside the parabola. I can see that it's a backwards C-curve. Okay, so backwards C-curve is a negative y squared. So I'm going to set up my equation x equals my 1 over 4c. I'm going to leave that part blank. My, I don't know if I brought my white out with me. I'm in Miss Sankey's room today. Do you have a white out, Miss Sankey? Maybe, but I don't see it. So I will fix that later. Put a y in here. And I'm going to say minus my k squared, and I'm going to have my plus h out there. So to find that 4c, I find the distance from here to here. From 4 to 1 is a distance of 3, so that means my c value is 3, but this is supposed to be 1 over 4c. So it's 4 times 3, which is 12. Hi, guys.
Oh, hi. Well, I was going to ask if you had a Jada McKenzie in here.
They are in room 314 today.
Okay.
Yep.
Okay. All right.
Got it. Okay. And then my HK comes from here. And so that one is negative 2. So opposite. And then I'm going to have a positive 4 because it's the same. Final answer. Okay, let's do an ellipse. This was the most missed question on that test we took for this unit last week. Okay, vertices, I just like to plot them. It's a lot easier for me. Negative 2, negative 6. That's a vertice. Negative 2 and 4. Uh-oh. Those are pretty darn close together. Oh, it's a positive 4. Okay, positive 4's up here. Okay, so my vertices are going up and down, which tells me the value under the y squared is bigger. Okay, so I'm going to have my y squared here. The distance here, I'm going to have my x. Okay, so this distance here is 10, which means that the b value is 5. And then I square it to get this number here. So that's a 25. Okay. My HK is the middle point. So if I just go up 5, I get to negative 1. Okay, I can see my k value. So if it's negative 1 and I do the opposite, it's positive 1. Okay, let's look at my covertices. I have negative 5, negative 1. Okay, and negative 2, 4. Oh. Oh, 1, -1. Take it back. Okay, -1, 1. Wait a minute. 1, -1. Dang. That's 1, -1. Okay, so the distance from here to here is 6. That means my A value is half of that, which is 3. And if I square it, I get a 9. Now let's see what halfway between here would be. So if I go 5 and I add -5 and I add 3, I get -2. But I do the opposite. So I'm going to put my +2. Now you can use midpoint formula. A lot of you are doing that. You will get the exact same answer for your HK. As long as you pick one of these pair. Okay, so you can pick that one, you can pick that one. It should give you that HK pair. Okay, next is descriptive form. You'll have one like this that's an ellipse. Okay, so I like to take my x terms and put them next to each other, and my y terms and put them next to each other, and move the constant to the other side. Then I factor out my leading coefficient for each pair. Four times 6. I know I'm going into that other space there, but I'm not assigning. I'm not going to do 9 today. Okay, so here I'm going to add a 1 to complete the square. But when I do that, I have to go 9 times 1 to get to the side. I'm going to put that in color. This one was where my students would go wrong if you missed this one. Okay. And then here I would add 9 here. So then when you add to the other side, it's this one times this one, and 4 times 9 is 36. You can see Miss Hankey's room. I'm not in my room. They are testing in my room today. So let's see. Hopefully that was all showing earlier. Can't be sure. Okay. So now when I factor, I'm going to get 9 times x minus 1 squared plus 4 times y plus 3 squared. My 9's will cancel. I'll be left with 36. For an ellipse and a hyperbola, this number needs to be 1, and that's because it doesn't have a constant radius like a circle. So I divide everything by 36 to get the 1. And when you divide, I'll get 1 x minus 1 squared over 4 plus y plus 3 squared over 9 equals 1. Final answer. Okay, we're going to be asked to graph a few. A lot of my seniors have been asking me questions on number 13. It has to do with that denominator here. Okay, so if the denominator is missing, then that b value or a value, if it's under the x, is implied 1. Okay, and that's because that's the only denominator that can be invisible. Okay, so that would be 1. Okay, so I plot my HK. It comes from this one in here. So that's +1, +3. That's my center. Okay, technically it does not have a point on the graph. Okay, then for my A value, it is going to be 2. I square root the 4, so left and right, 1, 2, 1, 2. Okay, and I'm going left and right because it's under the x, and that's a horizontal change. Okay, then I look at that one there. I'm going to go up and down 1, and it looks like I got an itty bitty little ellipse. Oh darn, that's super tiny. Okay, I don't know why I did that. Well, okay, so domain is going to go from -1 to 3. my range is going to go from 2 to 4. Okay. Now, hyperbolas have a very similar setup. To begin, I find that center. Okay, so it's the same center as the previous one. Okay, I'm still going left and right 2. I'm still going, oh, this time I'm going up and down 3. Because the x is positive, it tells me that my graph is going to go this way. Now, some of you, where you were making your mistakes was your asymptotes. In fact, that was the most common error for hyperbolas. So I'm going to go back to drawing that rectangle because that's what's going to give you those asymptotes. I'm going to do mine in red. You connect the corner of that rectangle through your center. So when you're writing an equation for that, this is a line. The lines have the equation y equals, always y equals, plus or minus your slope times x minus your h plus k. And we focused on that a lot in Math 3. We've used it a lot in Advanced Math, but I've gone back and looked at Math 1 and Math 2 stuff, and it shows up way back then as well. It hasn't changed. So when you're doing your asymptote, it's y equals, you're doing your rise, which is 3, over your run, which is 2. And I'm going to use that hk from my center there of my hyperbola, which was 1, 3. Okay. Notice it is a positive 3 here because it's the same when it's not by its partner. Okay, now the other asymptote is from this direction. Okay, so it's exactly the same except I'm going down 3, right 2, so that's going to have a negative slope. Same center. Okay, you can write it as plus or minus and just use one line, but I wanted to make sure that you guys know that because some of you just didn't put the plus or minus and then it's marked wrong. Okay, now I'm going to connect those shapes there. Okay, I'm noticing that this one is not asking about the foci, it's saying domain and range, so negative infinity to negative 1, staple bracket, positive 3 to infinity, and my range is going from negative infinity to infinity. Okay, so here is where you're going to see a foci question. I think that's probably why I didn't put it up here. So for the foci, I would need it in standard form or graphing form. So I would take that 9x squared plus 4y squared equals 36, and I would divide that 36 on both sides, giving me x squared over 4 plus y squared over 9 equals what? Okay, so to find the foci for a hyperbola, they are going to be inside those curves. So you're using Pythagorean theorem to get there. So a squared plus b squared equals c squared. So that's 4 plus 9, which is 13. So my c squared is going to be square root of that. Or I have the square root to get rid of the square. Anyway, so then I'm taking that 13 and I am going to go from my bigger term here. Okay, so I think about my little ellipse here. This would be 3, 3, 2, 2. Okay, and it'll be something like this. Because these ones are further away, those are my vertices. I go towards the vertices, root 13. Root 13 is a little bigger than root 9, and it's a little smaller than root 16. So that means it's between 3 and 4. So I'd go up a little more than 3, down a little more than 3. But I can see that it's the y value that's changing. So it's not going to be here, that's an x value. Those don't even have a root 13, so my answer will be B. Okay. All right, let's see if there's any more on this worksheet. A few more multiple choice. Okay, center and foci, another ellipse here. Okay, so my center is -3, 5. So it's opposite, opposite. So I can keep that one, not that one, not that one. So it's between these two. And so notice it's just where am I adding it? Am I adding it to the X or the Y from my center? Again, for a, dang it, that was right. I did make a little bit of a mistake here. Darn it, darn it, darn it. For an ellipse, I want it inside. And so if you want it inside, you have to subtract, okay? So I should have known better because this, I said it was up 3 and down 3. And so if it's up 3 and down 3, then if I'm going a little more than 3, it's putting it outside. So I was thinking it was a hyperbola. One of the things I recommend is as you're going through the test, if you notice a mistake, go back and fix it. Same thing for my SBAC users or SBAC takers. Okay, so this one should have been a minus. Scratch that off. So it should have been b squared minus a squared to put it inside. Okay, that'd be 9 minus 4. That'd be a 5 equals c squared, or when I square root. So I'm not going up and down 13. I'm going up and down root 5. So that's actually A, not B. Okay. Okay. Now I still have that ellipse. I'm going to subtract to get that. So I can see that it's going to go here 6 and 6 that way. So that means my foci are still inside. I take my 36, I subtract 16, I get 20. That's going to be my c squared. And then I square root to get the c. Now notice these are reduced. So 20 does equal 2 root 5. And that's because if I do a 4 times 5, I get 20, which is a 2 root 5. I'm going left and right this time to get to those foci, so I'm adding and subtracting this from my x value. So that'll give me A. Here I know that this one is a parabola because it only has a y squared and no x squared. Okay, this one I know is an ellipse, and that's because my y squared is positive, my x squared is positive, and neither one here has the same coefficient. So different coefficient, both positive. X squared and y squared. Both positive. And different coefficients. Okay, now I don't think I put this one on there. I think it is on the final though, so it's a good one to go over. I don't know why I didn't assign it. It was definitely on that test that we just had, and so this would be a good correction for some of you. And so on this one, I know my HK is -2. +1. Now this is the one that had a typo and I told you guys to fix it. Okay, let's see if I can remember this. That's probably why I didn't circle it, because it has a typo. I might have to come back to that one. I know it's not right though. Let me see, it was going to be a y, I think it was a y +2, an x -1, and then I think I put the 16. Did that go there? I think that works. Okay, so I think that was the change it was supposed to be. So if I make that adjustment there, then I can see it's not here or here, because that's when the x squared is positive. So it's going to be here or here. And so then I look at that center, and I go, okay, my value under the y is a 4, so if I square root that, my b value is 2, which means I go from there up 2. Now notice I'm counting by 2's, so if I go from here up 2, that would be here. And that's not the case. Whereas here, I can see it did go up 2. So the secret to this one is look at the scale. Let me write that down, typo. Okay. Number 24, we're looking at those asymptotes again. So the asymptotes are from my center, 0, 0. Okay, remember? Okay, I go up and down my 8. I go left and right my 5. Okay, I'm going to make my little box. So my asymptote is rise 8, run 5. Okay, not, and then the other one would be in the negative direction. Rise over run, always. Okay, that concludes my worksheet 4.